Well, good morning, everybody. Welcome to day 3 of VidTrans 2022. I'm Wes Simpson, founder of LearnIPVideo.com and also a long-standing member of the Video Services Forum. So today, I wanted to get some people up here that really are experts in RIST technology. And specifically, what I want to do is invite the audience. If you have a question of any kind about RIST, I think there's a pretty good chance that somebody here on the panel will be able to answer your question. So if you have any, thoughts, concerns, things that you'd like to know more about, any of those topics, please come up. We want this to be interactive and useful for everybody here in the audience. So please, at any time, get up to the microphone. I'll call on you, and we'll turn it over to the folks that are here. So just want to introduce our panel. First of all, we have Rick Ackermans. Rick, you want to just give us your title?
Okay. Rick Ackermans. I am the chair of the RIST activity group. And my day job is I work for CBS Paramount as director of RF and transmissions engineering out of New York.
Okay. Next, we have Adi Rozenberg.
I'm Adi Rozenberg. I'm the founder of AlvaLinks. I've been a member of the RIST activity group since 2018. I'm also a director in the RIST forum.
Okay. Ciro Noronha.
Hi, I'm Ciro Noronha, Executive Vice President of Engineering at Cobalt Digital. I've been with the RIST AG since it was founded. And I'm also the president of the RIST Forum, so both engineering and marketing hats.
Okay. And last but not least, Sergio Ammirata.
Sergio Ammirata. I'm chief architect of SipRadius and the maintainer of the LibRIST library as well. And I'm also a director on the RIST Forum.
All right. So I wanted to kick off. We have a couple little application stories about RIST, and I just wanted to go through those, kind of ground the application in reality, talk about things that are actually installed and working today so that you can get an understanding and appreciation of what RIST does. And in addition to just talking about what the application is, I wanted to talk about why RIST was chosen. So the first one, now this is not new to the VSF audience, but it is something that's, I think, a pretty interesting application of RIST technology, and it's a live play out of a actual on-air television channel from Brooklyn, New York to Sydney, Australia, being delivered over the public internet. It's being delivered in a redundant fashion today. So we have 2 ISPs at the source. We have 2 ISPs at the destination. You can see that there's a geographic diversity at the source. And this is a 24/7 live linear feed. So one of the main reasons why RIST was selected was because they wanted to have bounded latency. They didn't want to endure the expense, particularly because they wanted redundancy. They didn't want to incur the expense of having a dedicated fiber link or dedicated satellite channel or anything along those lines. And this has been a very successful application. They've had extremely good performance, very good reliability, and RIST was a good solution because it was quick to deploy. It has the necessary delay characteristics that they were looking for, and it is native for transport stream, which is exactly what they needed it to do. So, moving on, this is an application from Sergio.
Okay, this is one of the major US broadcasters. They had the need to replace the internal IPTV system with a newer, friendlier one, easier to manage, easier to play. The players of the one they had before were native or required Internet Explorer, still today. So we created this system for them where RIST is involved in the transmission of the streams from the encoders to the media servers. And we call it on-demand RIST because we use the feature of RIST where it can be listening, or the LibRIST library in particular is what we're using in this implementation. The sender, which are the encoders, are listening to a port, and then any one of the media servers can go ahead and connect and retrieve that stream on the fly. And the media servers are smart enough that they don't open the RIST tunnel until there's a player connected to them. So this particular implementation, this particular use case has farms of server, load balancing, encoders on 2110, IP to IP, et cetera. It says 600 video streams, pretty much all the internal feeds created at headquarters. And this is just phase one of the project.
And why RIST?
Well, one is they're very much, this particular company embraces open standards. They want something that that is basically future-proof. And this met all the criteria, ease of use, reliability, switching vendors if they ever had to, et cetera.
Okay, thank you. Ciro, short to ship content over satellite.
Short to ship content of a satellite. So this is a big cruise line. It's a household name. And they wanted to deliver video to the ship. So they have an uplink facility in, I believe, Florida. They have an uplink facility where all the content arrives. It arrives over IP, but it's not, that part's not RIST. It's just a dedicated network. And the way to get it to the ship is through a satellite. Now, this is premium content, so it cannot be in the clear. This particular cruise line wanted a secure solution, and they chose RIST primarily because of two things: the security and the reliability. Because of course, RIST is a reliable way of delivering this. So they are. Secondarily, they also wanted to use HEVC for this transport because the satellite bandwidth is not plentiful in this case, and it's expensive, and the ship's moving, right? So they have then a whole bunch of feeds. They terminate on HEVC encoders that implement RIST main profile, DTLS level. The encoders connect to decoders in the ship. Again, RIST main profile, DTLS level, so you get both the authentication and the security and the packet loss recovery of RIST. In this case, they didn't care very much about latency. They just cared about reliable delivery, so we can use large buffers in the RIST. Now, what's interesting about the ship is the decoders bring it back to SDI, and then it goes again into a bank of encoders. Those will be H.264 encoders, because the video distribution system in the ship is over IP, but it's your traditional IP multicast little set-top boxes, and you just bring an Ethernet cable to every stateroom, and the set-top box changes the channel. But that part, since it's a local network in the ship, that doesn't need RIST or anything. It's just plain straight vanilla UDP to the set-top boxes, and they just change channels. So RIST is allowing them to do that the key part of this, which is the transport to the ship while the ship's moving with reliability.
So Ciro, you mentioned that it's using DTLS. Does that mean that if there's other ships in the cruise line, they each have to get their own individual satellite stream?
That's right. That's a decision they made. So it is the same encoder. It's a point-to-multipoint thing.
Okay.
Where you have a DTLS connection to every ship. So it is multiple copies of the stream, and they elected to do that for security.
Interesting. Okay. Adi, do you have something you'd like to share with
us? Okay, let's take something interesting. I have been involved with a teleport that for many years has been using a proprietary non-vendor solution, paying a lot of money, and they decided to go with RIST. Why RIST? Because they wanted something that gives them the same reliability but better performance. And the key winning part was the seamless switching and the ability to throttle and limit your protection. So the problem that they had is that they had to switch from fibers to internet delivery, and the internet delivery was bounded by at the destination because of download capability was not there. We're talking about streaming to Africa, to Seychelles, Maldives, all those places that they don't have enough bandwidth, and of course you don't have the fibers.
Right.
And the 2022-7 was a mandatory requirement because they couldn't lose any packet over that distance, and they didn't want to go to satellite because it was too expensive for such an application. So they chose to go with RIST, and they were very happy. The system kicked off, and in a manner of half an hour, they were up in the air, everything is working. All the bandwidth limitation were fine-tuned by the way of throttling, the ability to set the maximum bandwidth that you use at the RIST. Security was provided with, just like with the cruise ship, with DTLS. And they were very happy, and they were very surprised that the switch was so fast. Beforehand, it took them a lot of time to set everything up, and they had a lot of the problem with the bandwidth. But switching to that seamless switching, everything went out the door like in 30 minutes, and they're up and running. The project was supposed to be 3 weeks per site, and it was up and running in 2 weeks' time. It was just amazing.
Well, that's kind of too bad. I mean, you didn't get to go do a field service visit in the Seychelles or the Maldives. I mean, that would have been nice.
I didn't get to go to the cruise either.
Yeah, man, that's no.
Trial at sea just worked.
Darn. We need to put in a little hook, you know. Call home. Go ahead, Rick.
Well, you know, it's funny, you talk about not being able to get to go somewhere, and this is, everybody's going to say this is old news, but it's ironic in that it would have been astounding the last time we met in this room. 2 years and 3 months ago.
Yep.
And that's that we use RIST, and as my CBS had as well as other formats, because nobody could go anywhere. People couldn't come into the station. So everybody sat there all over the world and looked at RIST and other formats, from people doing newscasts, sportscasts, and entertainment shows from their home. And like I said, I'm sure you're sitting out there, oh, come on, Rick, tell us something we don't know already. But think about it. All this happened between the last time we actually sat in this room and now. So stuff happens quickly.
So was there anything particular about RIST that made it suitable for your application?
It is very reliable at low latency when you're dealing with consumer-grade internet connections. Mm-hmm. Anybody who has cable internet at home, as do a lot of our news reporters and on-air talent, knows it's extremely asymmetrical. Your ability to do an upload, which is what's critical for air, is all crammed in that 48 megahertz and down, 42 megahertz and down spectrum. So it is far less reliable than the upload. And RIST, if latency is an issue, RIST has proven to be very, very reliable at getting that on the air, whether it's for news, whether it's for sports, or whether it's for entertainment, all of which over the last 2 years plus has been insanely used.
Wes, can I add something?
Yeah, please, go ahead.
If we're talking about COVID, in this particular project, one of the things that was an advantage using RIST that they couldn't do before was we established the DTLS tunnel, the RIST main profile tunnel. Now that tunnel is bidirectional. You can carry it's not like send one direction to the ship. If you go to the Maldives, to the Seychelles, and you create a tunnel, now with the tunnel, we could control the devices that were behind us, meaning that you didn't have trained personnel to be on site. You just deployed the solution, create a tunnel. Now you can control devices, encoders, decoders, PTZ cameras, whatever you need, you can do that from far, far away across the big pond, control that using the RIST advanced profile. This was a big advantage, so they didn't have to have any trained people on site. Just do the basic connections to the network, do the delivery, but also do the control. So many PTZ installations. I have an example for a cruise ship that we're doing, and they wanted to bring back the feeds, the RTSP feeds from local security cameras. They have a tunnel, send it back, and that's it.
Makes sense, makes sense. So, again, I want to encourage anybody in the audience, if you have any questions at all about RIST technology, please step up. We'd be happy to try to answer your questions. So, gentlemen, what do you think has been the biggest impact of RIST so far in the market? Where has it really made the biggest difference in the overall community? Go ahead.
Well, the support of 70.20.22.7. Yeah, okay. The inherent support of 70.20.22.7 was the biggest impact. Unlike other protocols or proprietary protocols, that was the killer application for most installations. The ability to carry your stream over multipath path, reaggregate that. If a path goes down or there are errors, it is fully redundant. Everything, it's low latency in some cases that they just use smaller buffer. That was the killer application. This is something that the proprietary protocols or the SRT till yesterday couldn't provide. The only alternative was to go hot and do switching. But then you have a hiccup. With RIST, you don't have that hiccup. That was the big killer application for many installations. That was a design win time after time.
Yeah, I agree with that. We have multiple systems deployed that were deployed just because of that. We have a customer where they have a decent internal network, but it's a TV station group. They have a decent internal network, but of course every station is also connected to the internet. So -7, one uses the decent internal network, and the other uses the internet. And as I just said, we look at stats in that system, there is hardly ever a retransmission because you don't have to. Most packets make it. If it doesn't make it in one link, makes it in the other link. But continue with what Wes said, is the flexibility of RIST and the ability to choose between vendors. You're not locked to a proprietary solution. You're not locked to a single vendor. And our users like that. You can just mix and match. So they may buy from a single vendor, but they know they aren't locked. If that vendor doesn't work for them, they can change. They can put something else.
In my experience, the most valued feature is the multiplexing capabilities of RIST. The ability to, instead of having to create multiple tunnels for each stream, or one per each stream, you can multiplex them all together and manage your bandwidth as a whole. That made a big difference on a lot of the installations that we did.
So the firewalls and things like that?
Mm-hmm. Not only firewall, but bandwidth management.
Okay.
Having one stream instead of 5 or 6 or however many doing packet recovery.
Makes a lot of sense. So putting on your forecasting hats now, if we were going to have this conference, let's say 2 or 3 years from now, what do you think, is that going to be an enduring feature that is going to make RIST important, or do you see something in the pipeline that's going to have a big impact over the next 24 to 36 months? Sergio, you have something?
Yes, I think the biggest feature that's going to come to the front line is the ability to do the VPN-like connectivity.
Okay.
Truly manage devices behind the RIST tunnel, cameras, proprietary equipment. I think that people are starting to realize that why do I have to have all this complexity, VPN servers or this or that, if one tunnel can do it all?
Yeah, but it's not just that, because that we had 2 years ago with advanced profile. With main profile. We had the VPN. You could put any kind of traffic, but the quality of that was the quality of a network. You relied on simple profile for the media, and then you had a tunnel that had the same quality of the network. So this is why there is such a thing as the advanced profile, where you have not only you have a VPN with all the protection, all the security, authentication, and encryption, but also with the advanced packet loss protection. And I think that's going to be key.
Okay. My take is that in 2 or 3 years, everybody will use advanced profile. That, just to top on what Ciro said, the advanced profile is an amazing piece of technology as soon as it will hit the market. Not only we provide a pipe, secure pipe, so no longer do you need to know whether I'm using what protection do I need to put on a stream by stream, but the protection is provided on the tunnel itself. You can put TCP, HTTP, NDI, SRT. You can push 2110. It's 2110 native. So it's not limited by bandwidth. It's only limited by the implementation and the innovations of the people doing that. Suddenly, the tunnel itself is important. Not the stream just goes into a container, it can reappear. We added flow identification, a lot of parameters that will allow it to work with SD-WAN, to be cloud native, to work in a cloud environment, multi-cloud environment, hybrid environment, with 5G, with satellite. Suddenly, you don't care about whether I have ZigZag or whatever. If I have a RIST advanced profile tunnel and topped with RIST relay, you can use amazing applications will sprung out of that. So we will not talk about RIST simple profile. We will say, oh, I need to take a stream. I will just push it through a tunnel, and the tunnel will give me whatever I need. It will classify my data. It will identify that this may be an NDI, this may be a 2110 stream. It will let the destination know that here something is coming, be ready, allocate your resources. Suddenly there's more information going through, more metadata going through, so it will allow new application to arise as a single environment.
All right, I think we have a question. Make sure the microphone's turned on. Go ahead. There's a little switch on it.
Hello?
Good. Thank you.
Okay. Since you're mentioning all this tunnel stuff, I guess I would ask you to compare and contrast. Certainly in the Linux land, there's a lot of widespread usage of very, very simple, almost zero configuration tunneling solutions, like from Tailscale, for example. That is wildly popular. I don't know if you've heard of them, but it's like ridiculously easy to create tunnels with ACLs and everything with that. And then all the things that you're saying, you're claiming as advantages of tunnels are all true in that case. So I guess I'm wondering, you know, why, if I can set up a tunnel so easily already, why do I need to use my video transport solution like RIST in order to set up a tunnel for me? So please explain.
Okay.
Yeah.
Should I?
Yeah,
Okay. So think of this notion. Until now, the tunnels that you had, they were only pipes. Any packet recovery, any retransmission, you will have to use the standard protocols, TCP, you will use simple profile RIST, and that will go through the tunnel. Setting up the tunnel is very easy. The RIST tunnel will be very easy for you. You decide whether it's a server or a client, you decide what kind of an encryption authentication method you want to do. It can be PSK, it can be DTLS, it can be even WireGuard. But unlike the traditional WireGuard, suddenly we will provide protection. Now you don't think about recovery. The tunnel itself, it's like going on a turnpike. They will provide all this, the tunnel itself provide the services for you. If a packet gets lost, the tunnel itself will do that instead of you. So if you want to carry TCP from New York to Australia, with the tunnel, you don't care about any TCP retransmissions.
With the RIST tunnel.
With the RIST tunnel. The RIST tunnel will do the retransmission for you. Hold on, don't jump. Now, on top, It can also, you can also decide as advanced users whether you want to expedite some of the traffic, prioritize some of the traffic, so you now become a more advanced user. So if there is a TCP traffic that is much more important and you don't want to wait to hold it so that the TCP itself will do the retransmission, you can. So suddenly there is a tool that gives you much more capabilities than any VPN, commercial or open source, available today to do that.
Right, so let me make sure that, let me try to summarize what I think you said, is like, if I'm using a tailscale tunnel, which is a WireGuard tunnel, and I'm sending a RIST stream over it, and I'm also doing like HTTP stuff, TCP-based stuff, that the tailscale, any errors that happen when the tunnel is going on, the RIST stream will take care of it itself, and the TCP stream is up to its own devices to be able to fix over tailscale.
Using something other than the RIST advanced
right,
profile.
If I'm on like
right.
a tailscale,
You can
traditional WireGuard tunnel, but if I use advanced profile tunnel from RIST, then it is going to be fixing the packet loss before the TCP system ever sees it.
You can select.
And I'm wondering, like, have you actually tested that? Is that true, or is there some kind of a strange interaction that might be occurring?
I can tell you that before starting the bucket list for the RIST Advanced Profile, I did a project like that. It's a skunkwork project that we tested the technology. And yes, it is amazing. We used TCP proxy, so that we basically said to the TCP, hey, don't worry, it's a long haul. We will just give us that, we will acknowledge the packets, and I can tell you, for instance, we tried to do, we tested that to deliver content to Twitch. And what we did, we had a problem, so let me explain what we did. The problem was that we had a limited upload bandwidth. We have a Twitch e-game, we have an e-gamer fellow with Twitch, and he had an upload problem. So the first problem was that we needed to bond interfaces, and we couldn't. So we did something which is like a RIST Advanced Profile, and we bonded. And then we saw that the Twitch wants to receive RTMP, which is TCP-based. So we terminated that TCP-based at the source, carried that using RIST to the destination, and then output that. So all the packet loss that was from the source to the destination, which was about 3%, which limited its ability to cross over, just flew out the window, because RIST, 3% packet loss for RIST is a joke. Like, RIST can do 40, 50, 80% packet loss if needed, and that solved the problem. So suddenly, we could increase the upload from 2 megabits to almost 8 megabits, take all the packet loss that the TCP will shorten its window or increase the window, depends on the situation, and that went out the window. So while the advanced profile is still, there's no commercial implementation of that, it is doable, and it was tested to achieve that.
What are you guys waiting for? The spec's been out for 3 weeks now.
The problem is that we need to travel every few weeks, coming here,
all right.
there.
All right,
Yeah,
don't whine to me about your personal life.
And yeah, we have to go to sit in AG meetings and
There you
write
go.
documents.
Oh, those terrible AG meetings.
Yeah.
But I know what you mean, Mike. There were, way back when, there were TCP-based VPNs, and those had very, very weird interactions, TCP over TCP, that basically they stopped working after a few days. But this is the other way. You give TCP a perfectly clean link, and there's a whole bunch of other things on the side too. For example, fragment level ARQ. You want to send big jumbo packets? Be our guest. We're going to deliver the packet of the same size in the other side. And you know what happens with jumbo packets or packet fragment on the internet. If any fragment doesn't get there, it's almost a denial of service kind of thing. We took care of that for you. Yeah, we dropped in things like, for example, compression. Yeah, it's there. Same thing as IPCom.
Lossless, mathematically lossless compression.
Lossless compression. And something that Ajay reminded me that it's not published yet, but it's coming, is the adaptivity, which we started by thinking, oh, well, we are going to write a specification for varying the encoder bitrate based on network, basically on packet loss network condition, right? Which it's not a new thing. Lots and lots of people, all the cellular bonding guys do that, but they each do their own thing, right? So that's coming. But then we realized, well, thinking, this is a smart guy here told us that if you're in a multi-link situation, you can actually adjust the weights on the links. So instead of calling it encoder adaptivity, we're even calling it source adaptivity. You want to talk some more about that?
Yeah. So basically, this is another thing that will be available in the it will come as a TR6.4, but it will be available for simple profile, main profile. It is friendly. The idea now is that to give you the same capabilities as the cellular bonding, or you can build a cellular bonding application. Now we test and give you the information on a link by link, what is going on a link by link, what is the health of the signal, and will allow the sender to decide what to do. He can go and throttle the encoder, the source, to change its bitrate, or maybe if we're going to have a CMAF, to select a different CMAF profile, as the guy from ATEM said, ATEM, yeah. It gives you more flexibility. But moreover, let's say you start with the 702022-7, but you see that your link is not the best. You can now decide to lower the amount of traffic that you send over that link, or maybe just use protection on that link if needed. It gives you much more visibility. But think about the statistics that you get. Suddenly you will be able to train your system, maybe add AI, so that you will decide which links to use, how to diverse your data, or maybe take out some services. Maybe if you are carrying, and I apologize, if you are carrying 2110, hold some of the metadata or the audio, but allow the video to pass through, or the other way around. It gives you you have more information.
Audio is more important, actually, Hadi.
Huh?
People complain more about bad audio than bad videos.
I know, but some people prefer to see the game and not hear the game.
Yeah.
It depends.
Well, the announcers, that's a different matter, yeah.
But
I want to pick up on something Ajay said here about the AI and stuff like that. It's a guiding principle here on the AG that we do only what's necessary for interoperability. So in the adaptation, we make the data available. But what you do with that is up to your creativity. So we have system A, system B, they will interoperate, one works better than the other. So we foster that part too. It's just like you take two video encoders that generate fully compliant bit streams, one looks better than the other. But they are both fully compliant, fully decodable.
Right, and that goes along the argument of why wouldn't I use a WireGuard tunnel and push the data? Because then you have to manage two separate tunnels, two bandwidth. If you push it all through advanced profile, the tools are there for an implementer to create a fully manageable pipe with QoS, with priority, the video on top of the other type of protocols, et cetera, so that you always get everything in one place to manage.
So I know we've been talking about advanced profile and TRO4 and things like that. Let's just take a step back for a minute and refresh the audience's memory if they're not aware. And all of this information is on the VSF website, by the way. So to date, there have been 3 major releases of the RIST protocol. So the basic one is called RIST Simple Profile. It came out in 2018. Then there was the main profile, which is the one that's most widely implemented today. That's what you saw down in the conference room. If you looked at the demo that we were doing, that was a RIST main profile. Our RIST advanced profile was released about 3 weeks ago, I think.
No, it was late last year.
Yeah,
But we just, yeah, okay.
we added thing.
Yeah,
Oh.
we've had.
We improved it.
That's right. We did
So what happened is we released RIST Advanced Profile late last year, and what was released recently was the levels document
Right,
for
that's right.
Advanced
That's right.
Profile.
Okay. And then we have TR04 or TR06-4, which is basically a wide collection of new features that are going out. So let's go back. RIST Simple Profile. Is that, I mean, we designed that originally to get something out quick, make it interoperable with SMPTE 2022-2 receivers. Is there a reason why people should still be implementing Simple Profile?
Well, it works. I know that people, few weeks before the official release, we already have early adopters that were using my solution, previous solution, and Cobalt in their infrastructure, and they're still using Simple Profile. I know of vendors here that use Simple Profile. They don't care for the main profile. They create a VPN and they push Simple Profile. It gives them the basic functionality of SMPTE 2022-7, and they're very happy about it.
Okay.
So it works, and also it is the lowest interoperability that we have. So
the
the simplest and the lowest one that everybody have to support. So if something doesn't work, you can still go down to the basics, and it will always work.
Sergio, did you have?
Yeah, I was going to touch on that last point that, whenever we're trying to troubleshoot the initial handshake, the initial configuration of two endpoints, if you have any doubt that maybe the parameters of the main profile are not the same or the encryption password or whatever it is, you can always just go down to the simple profile, verify connectivity, and then move on from there.
And you got to remember that a main profile doesn't do anything about background loss. So every main profile solution is running Simple Profile inside. That's only going to change when we have Advanced Profile deployed.
And let me just, throw in, folks have said too, if you notice, most of these have been updated. Some of them have been updated more than once. As we find ways to improve it, as some of the technology that this is built upon makes changes, we go back and we update these standards. So they are often living and breathing, and they're not static. So, don't say, oh, this is 5 years old, I'm not using that, because we've updated it. We have 2020, 2022 updates to many of these. So they're the latest and the greatest.
So again, anybody in the audience, if you have any questions, please, yes, Brad, we'd love to hear from you. You take off your low pass filter.
Really? I was wondering if you guys could talk a minute about your maybe short-term vision for RIST, and do you have an ultimate destination for it? And does the RIST Forum maintain a roadmap, or is there some kind of something available that would let people understand your vision for this? Because I know, Ciro, you said, I should brace myself for this onslaught of incoming documents. And I just wanted to hear, maybe not in kind of the very low-level bit, but kind of the larger vision of what's going on with RIST short-term and kind of mid-term.
Yeah,
Thank you.
Let me take that, because there's been an onslaught of documents. I'm writing them as fast as I can. Brad here is the gatekeeper.
Reviewing one right now?
Yeah, he's reviewing one right now. So I would say a lot of the core of the work has been done, right? So Simple Profile gave you reliability, main profile gave you security and tunneling, and Advanced Profile brought them together, right? So we can absolutely get it there. Now we are working around the other things, the extras, if you will, and that's
the nice to haves, yeah.
the nice to have. That's TR06, this TR06-4 series that's planned. So we're going to be working on those. There's source adaptation. The AG has completed the work. I just need to get off my butt and write it. The relay, the AG has completed the work. I just well, I'm not going to repeat that. The use of WireGuard with RIST work is complete. It's all just needs to, it's in the publication queue. And that's what's you're going to see in 2022. You're going to see those TRL6.4 part 1, part 2, part 3 coming out. But the big one, that's the one that we are working now, is the control and management. And that's a thing that I think is near and dear to your heart. Well, nobody likes that, but we got to do it, right? I said the word SNMP, everybody bit me, so I'm never going to say it again.
If I can just say something. We have a roadmap that was set in 2018 or even earlier. We just, somebody wanted the crawl, walk, jog, run phase. So we wrote that. We had a document that we published in late 2017 that outlined what we want to have. And we've been keeping track with that. The only new, I think the only new thing that we added was the relay. Yeah, that was the only thing that was not outlined there. So every bullet point that we set in 2017, we are keeping track with that. We said, what do we need to have? We need to have an interoperable protocol for security. That is the simple profile. We need to have the security. That is the main profile. Then we needed to have a pipe, which is the smart VPN. That's advanced profile. And then there was a lot of add-ons like adaptivity, encoded synchronization, control plane. We now want to have something which would provide us an ease of use to control third-party RIST-capable devices to set up all the configuration, and that will go somehow with interop with NMOS. We have IGMP optimization, and just from top of my head.
So let me jump in here. So Brad, to truly answer your question is yes, there is a roadmap, but we've been keeping it internal to the RIST activity group so far. If it makes sense to, expose that a little bit more, we should certainly talk about that and make it happen. But we've definitely been on a roadmap, kind of, like Adi said from day one. It was a crawl, walk, jog, run series, and I know we've shared that sort of internally within the VSF, but we haven't really made a big effort to expose it publicly. But
we had a slide in the talk you and I did last fall. We had a slide in that.
Yeah, no, I mean we do talk about it in the VSF, but we don't have a website and like the JTN or the Ames folks do. All that other stuff. We're not up in our marketing game with that. But
and for all these new features that we have pending to document, we now have the advantage of having feedback from the implementers, from deployments. And we've used that feedback to prioritize which document do we work on next. For example, one of the first one we put was the variable bit rate capability or adaptivity, because we knew there were a number of implementers or customers that says we need that. So we have the advantage now of having all that feedback and determine the priority of these last few items.
Yeah, that's the next one I'm writing, the source adaptation. In our plan, decoder synchronization came first, but feedback from the field is we want that part.
Yep. So again, if there's any feedback from the audience, any questions, anything along those lines, we'd love to hear from you. Brad, did you want to go?
Any feature request? Anybody wants a feature or something? New capability?
Yeah. I don't think we're going to be doing this in 5 years, though, having the RIST AG meet every twice a week.
Well, it's fun.
Yeah, but
what else are we going to do with our time?
yeah.
Right.
Go ahead, Brad.
So I think you guys have the benefit of having a marketing forum, the RIST forum. So I think it's perfectly fine for the RIST forum to determine whether it makes sense to expose that roadmap or to keep that as an internal document. That's up to you guys, I think. Two things that occur to me as follow-on to this, actually three. People may not, people who are just maybe hearing about this for the first time may not know about the adaptive, so you might just talk about that for a minute and what that is. And then another question that I had was just the feature set, as I remember, because now that you mention it, thank you, Addie, I do remember the discussion about crawl, walk, run, and sorting the list and figuring the feature set out. As you guys are working, you're pretty well along that list, or at least you have a plan to how to address quite a few of the things that are on that list. Have you thought about how to collect additional requirements? Do you want to keep this narrowly, basically the requirement gathering process kind of internal to the group and your customers? Have you thought about that? And so I'm piling topic onto topic onto topic, and I don't mean to jump your role here. I did have one other question about NMOS control, but maybe I should just...
let's hold that one, Let's unpack your first question. So I think one of the things that you're asking is, do we have a mechanism in place for, specifically for soliciting market feedback? And the answer to that is not really, but in effect we do. We don't have anything formalized. And where you see the biggest impact of our ability to adopt and adapt to the market has been, basically the prioritization of the things that we've already outlined. There isn't, I'm not aware of a lot of things. I think WireGuard kind of came up a little bit out of the, from the side, or from Adi. I don't think that was on our original roadmap, but most of the other stuff was. But we definitely are very open and very interested in hearing more about applications that are beyond what we already have. And I think that will be, something that we're going to have to do a better job of, outreach and soliciting input. So, but yeah, most of the other stuff has just been, working through our, as Adi calls it, our bucket list, and trying to punch through all those things and make sure we get all the things. I mean, encryption we knew was big. We knew fragmentation was big. We knew secure multi-protocol tunneling was big. So those are the things that we focused on. Now it's more of a, the fine details and add-ons that we're plowing through today.
The RIST relay was a direct request from a big potential customer. Say, yeah, it wouldn't be great if we could do this. They call it a rendezvous point. But, so that came out of that. Now, the RIST Forum does conduct periodic webinars and seminars to get the word out. And not very often, but it's a chance to talk to the masses and to the people and see what they want.
Yeah.
They, as I said, we don't get a lot of feedback, but as a mechanism for that.
Yeah.
Okay. And NMOS you wanted to talk about.
Yeah, well, let me just respond to that. I think that's fine. I think at some point, having RIST be done and then really focus on helping people to implement that and getting, if there are additional tools or reference implementations that you've been working on, if there are things that really need to be maybe more documented about, or whatever we can do along with whatever the VSF can do along with the RIST Forum to promote adoption of it, I think we get to some point where the major feature sets are done, and now we really need to work on making the adoption easy for the people that don't, haven't already been working on it initially. And, then there's always the point that as the group does kind of finish up, we need to think about people who come after the group has kind of spun down a little bit, and are there the artifacts that are left by the group to make it easy for someone to come in when they just don't have Adi's phone number on speed dial, or any of you guys' number on speed dial anymore. So that, I think, I don't have any particular direction one way or another, but I was just kind of curious where you guys saw yourselves kind of along that roadmap. And by the way, congratulations for how quickly you've moved through your list and all the features you've got. That's great. Control can be a very big topic unless it's got some guardrails around it, right? And so when I heard you guys mention control, I was just curious, as you're starting to think about that and maybe starting to unpack that box, where might those guardrails be? Can someone speak to that? Or is it too soon, right? Yeah, I know.
So let me just share one key thing with you, Brad, and I have to say we've learned from a master, yourself. We're very much on the requirements phase right now. So we really want to, we're not doing user stories, I have to admit, but we are very much going in and analyzing what are the functions that we need to accomplish before we're trying to very much stay out of solution space and focus on the high level. We have done some preliminary liaison with some of the folks that are very active in the NMOS community. Haven't really, and maybe I'm speaking out of turn a little bit, but we haven't, thrown something their way that's, really, ready for them to really start chewing in to. But we have made sure to keep them in the loop, let them know that this is coming and that we want their input and that we want to, the thing that's been great about RIST, and I think, you can see it from the folks that are here, and there's many, many more people in the activity group, is that we've tried to leverage existing experts, existing expertise, and existing technologies wherever we can. We do not want to build anything new. That is completely the antithesis of what we want to do in RIST. We want everything that comes out to be built upon the best available technology that we can find and implement it in a way that it's going to be easy and smooth for the community to do. So when it comes to control, that is in spades. We definitely want to have experts in the control realm influencing us, giving us guidance, and I think we can do a pretty good job of listening to them. So that's really important to me as the co-chair of the RIST AG, and I think all these guys share that same philosophy.
Yeah, we don't want to reinvent the wheel, and we want everything to be harmonious. If someone else is working on control, maybe what can we use of that? Can we work with them?
If somebody else is going to do it for us, great.
Yeah, well, it's said that a good engineer is a lazy engineer.
Yeah, right. Let me just make one comment and then please contribute. One thing I'll say, I'm looking for John. Is John in the room?
Who are you looking for?
John Myatt left.
Okay.
That's right. So I just will say, I'm happy to say publicly, that there's been a spirited discussion within the NMOS community about control. Imagine that. And John and another guy, Christian, have been heading up a lot of work within the AMWA community on control for NMOS, and they've come up with a way to do that that's quite a bit based on the AES 70, and you guys probably know that. There is another community within the AMWA that really would like to see a light kind of IoT, just pub-sub type model. And so I would just say that there is some healthy, I think, tension and ongoing discussion within the AMWA about how to do this. And it might be useful to have some input in terms of your user requirements, and specifically looking at maybe at complexity, and level of detail of control required and so on. So it might be an opportunity for your group and the AMWA NMOS control guys to kick the ball back and forth to really find that appropriate kind of methodology. And I don't know, it might be that there are two different methods, right? Because the guys who are on the train of the lightweight pub sub NMOS kind of IoT thing, are a lot of what they're looking at is scale, right? So a lot of that kind of approach to control really has been taken in the internet world because you're talking about scaling to millions of transactions per second, right?
Yep.
And then some more toward John and Christian's group is a very methodical way to go in and query devices and discover all of its capabilities. We have to traverse trees in there and so on. And I would say, and I don't mean this in a pejorative way, it's a more traditional approach to control. It's very thorough and would be something that I think a broadcast automation engineer would look at and say, oh yeah, I understand exactly how this works and this is what I would expect. When they look at an IoT type of control world and go, I'm not so sure I'm comfortable with this. So I think a little input
Yeah.
and dialogue would be a great thing to have there. So
That'd be great.
Thank
Yeah,
you.
I think if you could help point us that way, Brad, that would be very helpful. And I think you're watching the clock, not me, but at least one more question, please.
Okay, and this will be really quick, I think. But in the spirit of not reinventing the wheel, I wonder if you can explain why you couldn't use turn and stun servers, which are IETF standard implemented everywhere, used by things like WebRTC, and instead you had to design a coordination server that seems to do the same thing regarding NAT traversal enabling. So why couldn't you use those existing standards that are available?
Okay, thank you.
Well, that was the first question that the AG member from Zigzee brought up. And the functionality that was needed was a stun or turn server will allow you to traverse a NAT. But we wanted more than that. The requirement was that the RIST relay be able to discover devices that are connected. You will be able to provide encryption, security, or also traverse different encryption methods. So you can connect by a DTLS and then connect to a PSK-based vendor. A turn or stun will not give you that functionality because the encryption just doesn't, they don't talk the same talk. A RIST relay allows you to have one leg in DTLS, another leg in WireGuard or with PSK, and they will be able to communicate. We will basically provide the communication layer between them. Also, the applications that came out of that. For instance, something that my friend didn't mention that much. A RIST relay is a choke point. What happens if that goes down? So we said, there needs to be redundancy, handover or resource management. If I'm overloaded, if you want to connect, go over, switch to something else. Here is the IP, go do your stuff. A stun and turn will not give you that capability. So we started with something which was very simple, and stun and turn could fulfill the need. But looking into the advanced profile and the plurality of encryption and authentication method, we saw that there is a limitation. We wouldn't want to have one solution for PSK, another solution for DTLS, a third one for WireGuard or in the clear. We wanted something to unify. Then when we thought more, we said, wait a second, we can do more functionalities with that. I can now have a single tunnel from my organization, from RIC organization to a relay server, using one port, or maybe two if they want to have a redundancy, and it gives them better security. So they don't need to open ports, whether they are dynamic or not. Then if I want to do a distribution, I want to distribute the content to multiple locations, suddenly I have a relay that can fulfill that need. I want to send to 1,000 destinations. I don't want to create 1,000 tunnels. I can send one stream to a relay, and that relay can duplicate that to 1,000 duplication for me. So the bandwidth requirements on RIC, instead of sending, let's say, 20 megabits times 1,000, he only sends 20 megabits, and the RIST relay, which will probably be in the cloud, will do the duplication for it. So we started with something very small, But as we added more and more requirements and features, suddenly it grows to something which is much more.
But we were ever vigilant about creeping elegance.
Yes, ever vision of
So, yeah, the way when we started that job, that's exactly what we did. We went and looked at stunt and see if there was anything we could reuse. And the conclusion, no, it doesn't have the features we want.
Yeah.
We decided to design one.
And just to be fair, you know, we had, I can't remember how many times we took hypothetical reporters from a hypothetical news organization and put them into a war zone and said, now how is this poor soul going to get their content back? Because, you know, really, I mean, our focus has always been, you know, balanced, but I think, you know, we very much keep in mind the true professional quality applications that a news organization or a sports organization, things like that, want. And whereas, you know, you can build redundant systems by, you know, duplicating things, and you might have some switchovers and things like that. Our goal has been to build in that, you know, very, very high level of reliability from the start. We think that that's where RIST has, you know, if not the lead, certainly is one of the leading contenders in the market today as far as the ability to have protection, have encryption, have authentication, have authorization, and have, you know, the super reliability that, you know, somebody that works for a major news organization needs in order to do their job effectively. And so that's, you know, maybe we have, you know, built on a few more extra features that you might not need for, you know, a bunch of Twitch users to get into a game site. But, you know, our design goals were a little bit loftier than that. We really need to have stuff that's going to be working for our professional target customers.
Right. Regarding the reliability, another feature of the relay is you can use it just as a registration endpoint. The data doesn't have to go through it necessarily. You can contact it, say, I need to connect to this other. It's going to tell you, okay, that particular device is on the internet, go talk to it directly. And then you don't need to talk to the relay anymore.
I just want to add up. You would be amazed how many ISIS, Taliban, Pakistani combatant and reporters were perished in the discussion. Time after time, we kidnap reporters, put an ISIS combatant there, and then we see what will happen if they will start streaming to a news organization. So that is coming on, when we spoke, that was the use case that we tried to solve.
Preceding comments do not necessarily represent the views of RIST and everybody else on the RIST panel.
Okay, so let's just tie it up here real, you know, we're about at our time limit here. So to my panel, are there any things that you think that RIST needs to add specifically to work in a, you know, total cloud infrastructure? Are there things that are missing that should be on our bucket list? And you know, given all the cloud stuff we talked about for the past 2.5 days, you know, did you come away with any inspirations?
Well, I've always had the long-term vision that we should create a WebRTC-like protocol with RIST.
Okay.
You know, strip out the built-in mechanisms they have in place and put one that's more reliable, and create something equivalent that the browsers can implement that uses RIST for.
So a zero code browser.
Correct.
Okay. That'd be a nice trick. Go ahead. Yeah. Ciro, did you?
Well, cloud-wise, the protocol itself and the cloud are compatible. I mean, all
Sure.
these guys here have cloud instances of RIST. So, to be completely frank, maybe we're already there.
Okay. Rick? Go ahead, Adam.
So my take from this session, two things. A, I would like to see how we can add SRT support to the RIST relay to carry RIST advanced profile. This is one thing to improve on the SRT and interoperability. The second one, by the way, we did propose WebRTC in 2018 I did, and also put Quick on the table. We may want to support Quick, so maybe we will have to go. So Quick and WebRTC are the things that we need to consider, how we can do that. Quick being a part of HTTP free is coming, so maybe we need to see how to do that. So and those things were on the table, way back. And we just wanted to focus on the RTP.
Well, if we're talking about, you know, where we're headed, and I think that's what the question was. I mean, obviously, we are working on RIST Relay. Obviously, I have a lot of need for something like that. RIST Cloud, the ability to obviously better support large distribution, point to many multi-points. Once again, there are implementations out there, but more standardization on that. Can't imagine why I might be looking for something like that. But that's sort of where I'm looking for, the ability to take stuff and go through a cloud or a relay-based architecture. There may be personal reasons for that.
Yeah,
That's
but
okay. We
have-
like having users on our panel.
We have the mechanisms.
Right.
Just
Yeah.
someone has to go implement them.
Yeah, but we can always go a step further and define SDP extensions for the RIST protocols and things that are clear, that can be used clearly by the community.
All right. Last chance for questions. Anybody? All right. Well, I'd like to thank our panel, Rick Ackermans, Adi Rozenberg, Ciro Noronha, Sergio Ammirata. I'm Wes Simpson. Thank you for your time today. And thanks for the great comments from the audience. Really appreciate that. And anybody who's interested in participating in the RIST activity group, we meet every Wednesday at 11 a.m. Eastern Time. If you're a VSF member, let us know. We'll add you in. We're also very interested in having people join the RIST Forum, which is more of a marketing organization. We meet every other Wednesday at noontime, and we have webinars and newsletters and all sorts of other things that we produce. So we'd love to have any and all participation from anybody in this audience. And so thank you very much.